All right, so hello everyone, and welcome to this session. And again, thank you, Kasam, for organizing this. So today's topic is a little bit different. So I want to discuss about building cleaner business rules with JSON Rules Engine and Azure Functions. So today's topic will be more like a mix of demo plus a little bit of thought leadership on what rules engine is and how you can use it, and probably evaluate if it serves the requirements that you have for your organization or a project. So before we begin, a little bit about me. My name is Mandar. I am a manager at Accenture, and in my day-to-day responsibilities, I am an Azure and Power Platform architect basically. So I work with different projects of Azure as well as Power Platform involving uh, CRM, your logic apps, integration projects, data projects, and so on. Right? And I also do a not that much, but a little bit of development on the side when the project calls for it. And I am an agile and continuous delivery enthusiast, so I like to talk about these things. And you can reach out to me on Twitter using my handle Kodi Dharma, or you can connect with me on LinkedIn using my name Mandar Dharmadhikari, right? And you can check out the demo, or rather the code of this demo that I'm going to show you today on my GitHub repository Kodi Dharma. All right, so let's talk about a problem scenario. So I have been primarily working in a BFSI sector for a long time now. I've worked in banking projects, I've worked in insurance projects, I've worked in even fintechs. So what I've observed here is that the BFSI sector is generally very heavily regulated by the regulatory authorities. So if I talk about India, these uh, so if I talk about banks, they are generally regulated by RBI. If we talk about say stock market brokers, they are generally regulated by SEBI. If we talk about insurance, they are generally regulated by RDAI. Right. So all of these companies in BFSI sector are generally regulated by one or more of the bodies. Now the problem that creates is that whenever these companies or these players are creating out products in the market, they need to be according to the rules that are set out by these regulators. Another scenario in the BFSI sector is that the customer demand keeps on changing over a period of years, right? So these two things coupled together force a player in the BFSI sector to be very agile in which they are delivering the products and making them available to the customers. Now let's understand what I just said with an example. Now, if you have read the news, once the COVID was over, the central banks in America are doing something that is called as a Fed rate hike. And RBI has been following suit and doing same thing in India, right? So they are increasing the rate of interest at which they are giving loans to the bank. Right? So what this does is it allows the banks, so bank meaning not the RBI, but a bank like State Bank of India or maybe HDFC Bank, right? So what this change in interest rate allows these banks to do is that they can increase the rate of interest they charge on a home loan or a personal loan that they are giving out to the customers, right? So with changing loan rates from the RBI, the banks can change the rate of interest for the loans that they are providing, as well as they can change the rate of interest they are providing on the FD rate. So whenever the rate of interest or rather the rate is hiked by RBI, that generally accompanies with hiking in the rate of home interests or the interest given out on the FD. Now let's so if we tie this up to the agility, so if a bank is not agile in changing the products or the rules how a loan application or a FD application is processed and give out a way to provide the latest interest, it becomes difficult for the bank to survive because agility is required. So as soon as RBI or central bank makes a change, the bank should be able to make that change, right? So that's where the agility comes in. So let's understand this with a sample scenario. let's say we have Anita who is 65 years old and she wants to buy a fixed deposit for 6 months, right? She goes to a bank called as Good Banking Corporation and she says that I want to do this FD and this is my application, right? So I'm 65 years old and I want to do a FD for 6 months. So what banking corporation does is it goes to its internal implementation and decides that they need to give her the senior citizen rate of 4.5%. Now again, the numbers are made up, but I'm just trying to explain it with an example. Now let's take second person. So Raj goes to the same bank and he says that I want to buy a fixed deposit for 7 months. Now Raj is 35 years of age and then the bank's internal rule system says that Raj needs to have a regular citizen rate of 4.3% on his FD. Now, if we try to translate this rule engine, so what basically is happening is that the bank is having some sort of so bank is having some sort of rule engine in the back which takes the parameters like the age and the duration of the FD in months and then determines what is the rate of interest that we are going to give on that FD, right? So that is our problem statement now. How do we implement this and how do we implement it in such a way that if tomorrow if the RBI hikes or decreases the rate, this rule engine's output should change accordingly, right? So if it is hike, then we can change the 4.5 to say maybe 4.7%, 4.3 to 4.5%, or if the RBI decreases the repo rate, then maybe we decrease it to say 3% or 3.5%, right? So on and so forth. So a standard way of implementing this rules system that we just saw that determine based upon age and duration of months calculate the rate of interest given. So the traditional way of doing this is the imperative way of programming, wherein we provide or create a path, if you will, of if else and sequence if else sequences, so that we have a clear path of how the decision is flowing throughout the program, right? So if you see at this interest calculator that I've created, it has a simple method called as calculate, takes the application details, and then basically it is running these if else condition on it and then determining, right? So if, for example, if the age is greater than or equal to 60, then we are doing checks on duration of FD in months and then returning a proper interest value. And then we go ahead and return the interest percentage that the bank can provide on it, right? So this is called the imperative programming model, where we are defining the decision flow using a set of sequences, using the conditional operators like if else and switch cases. Now, what are the cons of this approach, right? So if you see the code that we had, there was a tight coupling between the rules and the service, right? So when I say rules and the service, so this calculate is nothing but your function which will ultimately be deployed as a part of a service, be it Azure function, be it a microservice, whatever it be, right? So this will be inside a service and the rules themselves are embedded into this function, right? So this function contains the logic for calculating the rate of interest in our case. Now the problem with that is every time there is a change in the repo rate by central bank, and if we want to hike or decrease the rate of interest for our FD, we need to go and change this implementation every time and then deploy it, right? So this is one of the major cons for this, right? That there is a tight coupling between the rules and the service. And as you see that it's an imperative model of programming, it has a sequence of if else and switch cases. It becomes difficult to maintain when the number of rules are way more, right? So I have shown you an example which takes into consideration only two parameters, age and duration of the FD. Now, if you take a case of a loan application, that will be way more complex, right? So that code becomes difficult to maintain because you'll have to have multiple classes, and then you'll have to have multiple sets of logics implemented in different places, right? So you are increasing your coupling, plus you are making it difficult to maintain the classes itself because the classes themselves contains the implementation of all these rules. The third major con of this approach is that every time that we make a change, as you saw that the implementation of the service or that calculate function contains the rule itself, we need deployment for any minor change that we make. Now, if you have a CD a continuous delivery system in your organization or a continuous deployment system in your organization, this might not be a problem, right? But generally BFSI sector does not have CDs, right? That's what I've seen. Some of them do. I'm not saying that none of them use it, but generally BFSI sector follows long project lead timings, wherein right from ideation of a particular product or change in product to delivering it in production takes maybe at least 1 or 2 months, because it has to go through a certain set of QA checks and all, right? So deployment becomes a major problem in the BFSI sector if CD is not done. Right? Now, so the question comes, see, this is the standard way that most people know how to code this. So the question presents itself, how do we change this? Right? So that is where the rules engine comes to your rescue. Now, this is a quote that I've taken from the Bleaky written by Mr. Martin Fowler. So he says that a rules engine is all about providing an alternative computational model, right? So instead of your usual imperative model, which consists of commands in sequence with conditions and loops, that is what we just saw, the calculate function, a rules engine is based on a system of production rules. This is a set of production rules, each of which, now this is very important, that each of which has a condition and an action. Simplistically, you can think of it as a bunch of if-then statements, right? So now let's look at this rule, that calculate function that we had. Now let's translate this into something that Martin Fowler just said, that it is basically a bunch of if-then statements. So if we convert that logic that we just saw inside the calculate function, you can represent it like this. So you have your rule name, which identifies what that rule is doing. Then you have your expression, that is your if condition now, that if your input age is greater than or equal to 60 and input duration in months is less than 12 and input duration in months is greater than 1, then you're doing some action. If this expression is evaluated to true, you do then some action which is defined by on success, and you're saying that set the rate of interest to 4.5, right? That way you can define n number of rules using this if and then. So basically you would define a condition which if evaluated to true, you do something, or if it is evaluated to false, you do something, right? Now, what this allows you to do is it allows you to get rid of that particular set of sequences that we saw in the code, right? So these rules are defined as individual entities, and then you club them together no matter the order, and the rule engine itself, which executes on these rules, it determines what is the correct order, right? You do not need to specify the rules in a particular order to get the correct output. What is like what we did in the imperative way of that calculate function, right? So the rule engine, what it does is now that it decouples the rules from the service implementation. We'll just talk about it in a minute. Then this is very easier to maintain because the rules are externalized and stored in the rule store. So I'll discuss this again in a minute when we discuss it when we discuss how we implement this on Azure. Then third is that every change that we do does not actually require you to set up a complex continuous delivery system, but it just needs a simple deployment of a rules file. I'll show this to you in the demo. And the last one is that it is a cleaner way to implement the rules. Now let's look at this from Azure's perspective, right? How does it work? So you have your rules engine black box, which is your execution engine. So think of it as a black box wherein you're putting something and it is giving you back something, right? You don't know what happens inside, how it is processing that piece of information. You just know that you are getting a result out of it. So that is how this rule engine works, that you feed it the data that you are getting from the callers, that can be your logic app or web apps or mobile apps or even other apps, other rule engines, for example, right? So you're getting the data from them, you're feeding it to orchestrator. So that orchestrator, what it does is it basically goes to something that we define as a rule store. So the rules that we saw earlier, those JSON snippets that I showed you, those are stored as a long JSON file inside Azure Blob Storage that is completely externalized from the execution engine. So you have your execution engine, which is a black box. So what you basically do is you expose either a set of REST APIs, or you expose it as a PubSub mechanism, or rather a PubSub triggered Azure function, maybe through service bus, or you can do it as an event triggered one through event grid, right? But the gist of it is that the callers provide certain set of data on which your rules are executed. So in our case, it would be a FD interest application. So we are providing an object which contains age and duration of the FD. The Azure function gets invoked. The Azure function then goes to blob storage saying that, boss, I need this rule file, and then it retrieves or downloads that JSON file and then passes these two pieces of information, the data that we got from orchestrators and the rule file that we got from the blob storage, and feeds it to the black box. The black box does its magic inside and gives you back the calculated rate of interest, right? So how it does that, we do not need to know that because it's a black box. All that we are defining is using the if then statements inside the rules file that will be stored in the blob storage. Now, tomorrow, if we want to change something, all we need to do is we need to change the rules inside the JSON file, upload it to blob storage, and we are good to go. And we'll see this in a demo. So before we move into demo, let's quickly look at the libraries or the products that we are using for this demo. So we have this JSON rules engine, which is an open source rule engine supported by Microsoft, which basically allows you to code your rules in a JSON format. Now, this rule engine allows you to store these rules either in blob storage or Cosmos DB or SQL, wherever you want to store them, right? Or even as a file, you can store them. Now, it is very easy to integrate because of its black box nature, right? So you do not need to know how the rule engine functions internally. All you need to know is you need to define your rules, provide the necessary data, and the rule engine will give you the output, right? And as I just mentioned earlier, it supports writing rules using the lightweight JSON format. So it is very easy for developers to write the rules. And it has a very strong support for behavior-driven development. So how that works, let's talk again during the demo on that. Azure Functions, as you know, it's a serverless compute service by Microsoft, has plethora of triggers and bindings to integrate with various Azure services, example being HTTP, service bus, event grid, so on. Mostly developer oriented because you have to write, not mostly, but it is developer oriented because you have to write pieces of code, right? So it's not for some citizen developers because you'll need to have some experience with programming. It supports local debugging and testing, and this will be the major point in our demo because I'll be showing you how to locally run this rules engine and what are the advantages of doing that. Then it supports containerization and production slots. So the Azure function that you can write, you can create a image out of it and you can deploy it as a container, or rather in a container, right? And then the choice of containerization entirely depends upon you. It's just that you create a image out of it and you just deploy the piece of code, and it supports that. It also supports production slots, which allows you to do I believe it's called red-green deployment or green-blue, something like that. That kind of deployment wherein it allows you to deploy the production code to a slot first and then just switch the slots so that the minimum downtime is incurred between the switching. So that's another advantage of using Azure Function. And the Azure Functions can be run either on a fixed price service plan or it can be run on a cheaper version of a consumption based plan, right? So your fixed app service plan would be basically using an app service plan in the background, and you will be charged a certain amount based upon that particular plan. Again, on the basis of resources that are consumed, you can define scaling rules for it by tapping onto the metrics of the plan. For example, the percentage of CPU utilization, the percentage of memory that is used, or number of requests that are being processed, right? So you can do scaling in and out. So you can convert the lower app service plan to a higher one based upon your traffic and certain metrics that are suitable to you, or you can scale down as and when required. On the other hand, you have a cheaper version called as consumption plan, wherein you deploy the Azure function on it. The Consumption plan allows you to pay only for what you use. And again, there are certain free executions that are available for consumption plan. But once you cross that, you'll be only paying for what you use. Right? And again, this is a cheaper alternative, but comes with the downside that if you are not using the functional for a function for some time, I think ideal time is 20 minutes. The Microsoft functions platform unloads that function from the platform, right? So that gives rise to the problem of cold start. So basically, if you are not using your function, it will be unloaded, and the next time that you make the call, the function gets loaded onto the memory again, and then it takes some time for the first call to go through if the function was unloaded by the consumption in the consumption plan, right? So that's a downside of using consumption plan. So point being, choose the app service plan or consumption plan based upon your requirements. Sorry. Then the third ingredient is the blob storage. So blob storage, or rather the storage account, is Microsoft's object storage solution for the cloud. Again, it is optimized to store massive amount of structured data as well as unstructured data. So I forgot to add the unstructured part. But example being, it allows you to store JSONs, it allows you to store hard disk files, it allows you to store log files. Again, different types of data that you can store, and it's built for scale, and it's ideal for serving images, videos, static web pages, etc. So these are the basic components that are used in building this particular scalable and agile version of rules engine, right? So let's quickly now jump into the demo. Now I'll move on to my Visual Studio. So let me know once it's visible. So I'm assuming it's visible to everyone. Now, as you can see, this is your standard Azure Functions project, which is created by basically going to the file and creating a new project of Azure Functions type. And you'll see that I also have this project, XUnit project, which contains a lot of tests. So as I said earlier, this rules engine supports behavior-driven development, right? So let's talk about it. Now, the point that I want to make here is that the rules engine that you see that I'm working on is actually built using the concept of test driven development, right? So if you go ahead and visit this GitHub project, you'll see that there are a lot of tests that I've written for a simple one small part of Azure functions that I want to show you, right? So the crux behind that is that this is written using the TDD. That's why you will see a lot of this test, right? So meaning I have written the test first, and then the code is evolved through writing the tests through the TDD paradigm, right? But I'll quickly go through the Azure function first. So you'll see that there is this function that is created, which is called as execute rules, and it basically works with the HTTP trigger, and we are providing it a request which will be of this form. So if I go to the body, you'll see that this is the request that we are providing to the Azure function. So your evaluation inputs is nothing but a array of data that you want to feed to the rules engine. Now in our FD case, it's basically just one small thing that I need to feed the age and the duration of FD in months, right? So I'm feeding it the age as 48 or 49, 50, whatever it be, and the duration in months. Now, what this Azure function does is it basically gets that, parses it, runs a set of validations on it, like checking whether we are providing the name of the rules file along with it or not, and then feeds that to the rules engine using evaluation rules method, and that's it. The rules engine gives you back the details, and it returns back a 200 status, right? It also returns other statuses like 404, 400, not found, bad result, all of those status codes. But again, I encourage, if you like this new way of writing rules, right, which I'm about to show you, I encourage you to go to this project and see how Azure Functions is coded, right? A small note on what I've used for this, right? So let me just open the project file. You'll see that I've used certain set of extensions. So you have your Azure blob storage for connecting with the blob. So that what it does is this Azure function uses the method from this SDK and uses them to go and download the blob from a particular container, right? And that is defined using your repository functions. So you can see that the implementation is very simple. All it does is it goes to the takes the name of the config file, or rather the rules file, and it goes to that particular blob container and downloads the result and sends it back as a string. That's it, or maybe object, depending upon what you are using. So there are two methods. Then I'm using so Open API I'll cover last, but I'm using then rules engine, which is the main black box that I talked about, right? So if that is a NuGet package published by Microsoft, and we basically add that to the project and we write a wrapper on top of that, which I'll quickly show you. So this rule engine handler is nothing but a wrapper written on top of the rules engine interface that Microsoft provides, right? So if you see here, we have methods like add or update workflow, so which allows you to basically load that JSON file that we download from the blob storage into the memory of the rules engine. And then you have this method called as execute rules async, which allows you to execute the rules that are loaded or that are present in that particular JSON file. So let's quickly look at that JSON file as well, right? So if you see this is the rules file that I've defined, right? So you have your name of the workflow, then you are defining a set of rules inside it, right? So for example, if your age is greater than or equal to 60, duration greater than 1, and duration in months less than 12, you basically say that the rate of return or FD rate is 4.5, and you define the same thing here, right? So it's a simple JSON file. So what this rules engine does is it basically this wrapper does is it gets the rule config file that we downloaded from the blob storage and gets the input that we passed from the function, or rather were passed to the function, and then it feeds to the rules engine and invokes this method called as execute all rules async. And whatever happens inside, we are not privy to that, but after that we basically get back a response from it, which we are then transforming it into a DTO using automapper, and then we send it back, right? And that basically is the gist of it. Then I think the other one that I want to talk about is the dependent. I'm assuming everyone is familiar with automapper. If not, what automapper does is it basically allows you to write mappings between two sets of objects. So for example, if I'm passing something to a function, and if I want to convert it into something that is being sent to a database, I can write an automapper profile in between, which allows me to map fields from input to the, or rather from the DTO to a entity class, and vice versa, right? Then one of the important things that I want to talk about is, again, this is like a best practice that everyone should follow, irrespective of what type of function they are writing. If you're writing an Azure function in C#, use dependency injection in it, right? So if you see, in the past, the Azure function mostly was something like public static task something run, and then HTTP request or whatever it be, right? But it was a static version of it. But if you look at this implementation now, that you'll see that there is no static call in here. So it basically works with the concept of dependency injection. So you'll see that this execute rules class is my class which contains your Azure function, and I'm injecting all the dependencies that are required by this Azure function, all the repositories or all the handlers or all the utilities that we are writing. They are injected as they are injected as dependencies, and then you basically use that concept to make your code more manageable, right? So it is one of the solid principles, right? So It allow, or rather, my suggestion is that if you are writing a C# based Azure function, always use dependency injection, right? So the main part where you registered these dependencies is your startup class, right? So you'll see that inside your startup class, you can register the dependencies inside this functions host builder. So builder provides you a iService collection using builder.services, and then you register your dependencies either using singleton or transient or scoped, right? So if you want the instance to be constant throughout the life of the function, life of the, or rather the life of the function when it is hosted, then you use a singleton type of dependency. The good example of this would be HTTP client, right? So your HTTP client, whenever generally you're making calls to the external world using HTTP client, what we tend to do is we tend to initiate a new instance of HTTP client every time. Now the disadvantage with that is inside of Azure function, you only get a limited number of sockets, or rather web sockets, to make the call. So if you new up a HTTP instance every time, it will exhaust the sockets and you will get a socket exhaustion exception in that case. To avoid that, what you do is you basically create only one instance of HTTP client and you use the same instance again and again and again to make the call, right? So that again comes into the best practices. So wherever it's a resource heavy call, you generally make only one instance of it and you use that instance again and again to make the calls. Right? So the point being that you use dependency injection and you select the correct level for that particular instance as being singleton or scoped to a user or a transient based upon the requirement that you have. Right? So that's one thing that I wanted to talk about. Then the other thing that I wanted to talk about is the Open API configuration. Now, if you are familiar with Open API specification, it allows you to write excellent documentation for the APIs that you are exposing as the, say, in this case, REST services, right? So let me quickly show you a sample of what I'm talking about. So if you look at this, this is the Open API spec that is generated using the coding configuration that I'm about to talk, right? So this is again a NuGet package provided by Microsoft. You include that package, configure certain things, and decorate your function with certain decorators, and it allows you to create this beautiful rendition of your function, if you will, right? So you can define details like what your APIs are, then you can define individual functions inside it, right? So for our case, the function is basically execute rules async, right? And then you can define what are the headers that you need to pass, what are the request bodies, what are the responses that you are expecting, and all of this is done using code, right? You're not actually writing this using YAML or anything. So how we do that is basically we use this package called as Microsoft Azure Web Jobs extension Open API, and wherever we are defining our Azure function, we include decorators like these, right? So for every function, we define what is the type of security. So for in our case, it would be functions key that we are passing the function key as X functions key header, or we can define it as something that goes in the query parameter. Then you can define the operation that this Azure function specifies. So in this case, it would be execute rules async. So for example, if you're, let's say, building a microservice using Azure functions alone, and you have 4 functions defining the CRUD operations in it, right? So for example, let's take an example of order API, right? So it would have CRUD basically to create order, read order, update order, and a delete order, right? So you would create 4 different Azure functions inside the functions project, and then you would decorate each one of them with the necessary operations so that your Open API specs reflect that, right? So your one master Open API spec can be controlled by setting these decorators on the Azure function. So you have your other details like Open API parameter, request body, responses. So you basically show or document everything that your Azure function is going to accept or send out, right? And then you can do certain configurations for Open API by extending this Open API configuration options, wherein you define the basics, right? So let me quickly bring this back. So the basics that I mean, these details, right? So general detail about your API. So in this case, there is only one function, but the details are that I am providing the heading of the Open API spec, then that it is Open API specification 3.0, then the URL for that JSON file, then basic definitions, and then contacts and licenses, right? So all of that can be defined by extending the IOpen configuration options. And again, I know that I'm giving you too much information at this point in time, but my goal is to give you some sort of idea of how you would write a production grade Azure function. And I highly encourage you to go and check this GitHub project out and study it, so that you get an idea of how generally we write a production grade Azure function and how TDD helps in writing that, right? So again, I'm bringing up TDD, but yeah, I encourage you, if you like this, go ahead and check this project out and download it to your local machine, set it up, test it out. I'm pretty sure you'll learn few tricks, right? So that being said, now let me quickly show you a demo, and let me now again bring the conversation back to the rules engine. Now, as I showed you, this is the rules engine file that is deployed inside a blob rule store. So in our case, the rule store is a blob container. So you'll see that I'm running this locally inside Azure, right? And you'll see that I've created a container called as rules here. And inside rules, I've uploaded this, what I'm calling it as FD interest rates.json rules file. And the same you need to configure in your local settings.json. Here, something like this, right? That it basically asks you to provide the connection string from the blob storage and the container name. So you can do anything that you want here. You can change the name of containers to rules 1, 2, 3, 4, 5, 6, whatever you want. Connection string you need to give to point to that particular rules. Blob storage. Right now I'm running it on Azure locally, so I've given it a local endpoint. But in production, you'll basically switch it with the production instance of your blob storage and give the necessary container name, right? So we have pushed this file into the container now, and you'll see that it contains all the logic that we need for the rules, or rather all the rules logic, right? So you have your expression and you have what output needs to be feed out, right? So it is basically 4.5 if it satisfies this, right? 60 greater than 1 and less than 12 for the duration in months. And I've defined it again for the category age less than 60, and then again different combinations of duration in months, right? So how do we test this? So what I'm going to do is I'm going to run this Azure function locally, and you'll see that I'm again using the out-of-the-box tools that get installed with Visual Studio. And you'll see that this is the endpoint for our rules engine. So your rules engine is available over this endpoint. And then if you want to see the Swagger API that I just talked about, you can basically use the render Swagger UI function. Now let's quickly go to our Postman, and you'll see that the call that we are making to this local execute rules async function is a post, right? And we are passing a set of evaluation inputs to the rules engine, and we are passing the details of the FD interest application. Now, in your case, this can be a complex object wherein you define different inputs on which the rules need to be run. So if you see here, we have something called as name, and then I have this point called as age and this data point called as duration in months. Now let's for a second quickly go back to our rules file, and you'll see here that what I've done is I've used input.age, right, and then input.duration in months. So if we correlate this with the request that we are sending, it's basically the name of the data point that we are sending to the rules engine, and we are saying that inside this, read the age and read the duration in months and write some, or read the expression like this, right? That you have your name and then data points, and then run the rule. So if you see here, then I'm providing additional details like the name of the rule file, which I just showed you, FD interest rate and FD interest rates.json. Then we are providing the functions key, which is not required locally. And then we are providing the content type, and that's it. And when we execute this, you'll see that right now I've sent the age as 48 and the duration of months as 4.5. So you'll see that the result is 3.9, which is again defined in our rules engine, right? So if you see here, this is the rule, right? If your input age is less than 60, which is true in our case, and duration of months is less than 1. So we have sent age as 48 and duration in months as 1, right? So we got 3.9 back. Now let's try another example. We'll set the age as 65 and the duration of months as 11. So we should ideally be getting 4.5 back, because this is the condition that gets true and others are false. So let me quickly go here and let's change this to say 68. And let's do this 11.5 for example, and we should be getting 4.5 back, right? So 4.5. Now let me bring it back to the functional scenario that we had, that what happens if the RBI hikes rate by another 1%, for example. Highly unlikely, but happens. Let's say it happens. Then let's say that the bank wants to change this 4.5 to say 5%. So how do we do that? Now if I go back to my imperative, let me quickly go to that slide. If we go to our imperative model, just give me a second. Yeah, if we go to this imperative model, what happens is that if we want to say change this 4.5 to 5, we need to make the change in this calculate function, rebuild the code base again, deploy it, right? Those are the cons that we just talked few minutes ago. Now let's say if we want to do this with the rules engine, how would we do that? So all we need to do is go to this fd rates interest.json, change the 4.5 to 5.0 and upload it to the blob storage. Now I've made the change directly in the blob storage, but you would ideally do this in a source control manner and deploy it to the blob storage through a simple CD pipeline, right? So it can be a GitHub Actions or it can be a PowerShell script, some kind of automation. So that's it. Now, if we go back to our Postman and let's execute this again, and you'll see that the 5 instantly comes up. Right? So this is the beauty of the rules engine, right? So we have externalized all the rules from the service implementation. So you'll see that I have not touched the Azure function at all during this. All I did was make the changes in my JSON file, upload it to the blob storage, and that's it. The changes are instantly there, right? So this is the beauty of using rules engine, right? That you actually externalize the rules using if-then statements and you deploy it to a rule store. So once your framework, that is your Azure function and the rules engine is fixed, you do not need to touch that again, which is evident from what we did. I did not touch the code base whatsoever. I just changed this rule file, deployed it, and the changes are available to me, right? So let's analyze what it did for us. Right? So what it did is it provided us a lot of agility, right? So that the change itself becomes simple. The developer, while sitting with a business person, can make this change and get this code deployed instantly to different environments, right? So the lead time that I talked about in the BFSI sector, being 1 or 2 months for a change to flow through production, that can be reduced because we are involving the business persons from the start. They are dictating what the rules or changes that we are going to do, and those changes are completely externalized, right? So even if we fail with the rules that we have implemented, all you need to do is keep on playing around with this JSON file, and once you get it right, you deploy it through some sort of automation. So that gives you a lot of agility, right? So let me quickly move back to my PowerPoint and let's quickly discuss few points on the cons now, right? So when we talk about agility, right? So the agility was that it allows you to externalize the rules engine. You change it there, and that's it. You deploy the rules file. You are agile, right? Now, let me quickly, before we go on to the cons, let me quickly talk about the scalable nature. I have briefly touched about it when I talked about the app service and consumption plan of Azure function, but I'll quickly rephrase it. So if you check the architecture that we have here, it's nothing but your Azure function, right? And all the code is, or rather the framework, let me rephrase it, the rules engine framework is inside the Azure function itself, right? So you can deploy it as one function on your Azure Functions platform. Now, as I said, the Azure function itself can run either on an app service plan or it can run on a consumption plan. So based upon your workload, you can set up. So if you are using app service plan, then you would switch from one plan to another. So you can scale up or scale down based upon the resource requirement, and you can do that by manually scaling it up or down if you know that there are certain peak times when there would be a lot of load on the Azure functions, or you can write metrics based automation or scaling rules wherein you say that if my CPU percentage or utilization percentage goes above 95%, just change it to from plan B1 to say B2. Those might not be the correct name, but I'm just giving you an example, right? B2 being a higher version, which has more CPU and more cores, so to speak, right? Or sorry, more memory. Or if you know that, or you can write something that once you move to B2, there can be another rule which says that if the CPU utilization falls below 60, move back to B1. So that way you set up the scalability of Azure function for using the metrics and that automation for scaling up or down, or you can use the consumption plan for Azure function wherein the uh, platform scales itself up or down based upon the requirement or based upon the load. It's just that as I talked few minutes ago, it comes with a shortcoming of this cold start whenever you're not using the Azure function. So there are other ways of keeping the Azure function alive, right? For example, you can write a endpoint which continuously pings the Azure function to check whether it's on or not, right? Something like a health check endpoint, which keeps the Azure function alive after every 10 minutes or so. But again, depends upon your requirement. So the solution, since it's deployed as a Azure function, oh sorry, not the solution, but the framework itself is deployed as Azure function, it becomes scalable by nature because you have either the rule-based scaling or you have the automatic scaling of your consumption plan. So now let me quickly go through the cons of the rules engine. So as you might have seen, this is a completely different way of defining your rules, right? So it has some learning curve associated with with its use. Now, I've personally been using rules engine since last 8-9 years, so I'm comfortable with it now. But I'll be very honest, when I started implementing these rules first, they were very confusing to me because you do not have what is called as a you do not have something that is called as a clear decision path. So if you check the imperative way of programming, you have your sequences of if else or switch case statements, right? So you know how the flow of the program goes, that this is the statement one that will be executed, this is the second statement, this is the third statement. Now in the rules, if you see the rules file, again let me quickly pull this up. Even if I change the order of these two, I do not know which rule file will be executed first, right? All I know that if this condition is evaluated to true, I might get 5.0 out of it, right? So this is very difficult to understand when you are beginning because you cannot see the execution path for this. Even if I put all these input.age related or the regular citizen related rules first and then senior citizen related rule last, or even if I shuffle them together, the order of execution will still be determined by that black box, right? So that is very difficult for a new developer to understand and get grasp of. So that's why a set of, or rather some learning curve is involved. Now, as you might have seen, this is completely, the rules are completely decoupled from the execution or execution engine, or the rules and the service are completely decoupled. Now, the problem with this is that decoupling in this case is not always good, right? So you'll see that there is certain set of complexity that these rules engine introduce into the system. But if you're building a small system wherein the number of rules are very less, then the rules engine might not be the correct solution for you. So we point being that we cannot blindly trust the rule engine in every case, right? So you have to do a very careful evaluation of the complexity of the system that you are building. I'll give you an example. The FD interest rate rules that we just saw, those are very easy or simpler in nature, right? So if you have a proper CD in your system, wherein you have the capability of going to production maybe once or twice a day, then having such a simple system using the imperative way of coding using if else statement makes sense, because that is easier to implement, right? And you, since you have CD, the go to production becomes simpler. But if you have a system like an insurance system wherein you are trying to determine a premium for a let's say a aeroplane or a building or a ship, right? So there are a lot of factors that come into picture there which allows you to calculate premium for that, and those are called the rating rules. Now those rating rules, if you write them using this imperative model, you'll be scratching your head for a long time. So there switching to rules engine makes sense. So that's why a very careful evaluation of your use case needs to be there for you to come to a decision whether you want to go down the imperative path or you want to use the rules engine path. Yeah, that this point basically covers that. And yeah, those are the cons of the rules engine. And I think we are well in time today. So probably I'll pause for questions now. So yeah.